Hello, my name is Paul Bender. Welcome to School's Not Out, your daily classroom for CSEC and CAPE students. You can watch this lesson real-time on Television Jamaica's YouTube channel or on onespotmedia.com. We are also live on Music 99 and gojamaica.com. If you have any questions on today's subject on CAPE, you can send them to Television Jamaica's Facebook page or Instagram at television_Jamaica. Today, we're discussing projectile motion. Much of what we'll do in today's lesson may be revision for some of you, but we'll look at projectile motion, and the approach is a slightly different approach than you would have, but the hope is that at the end of it, you'll get a firmer understanding of much of what projectile motion is all about. So the objectives for today's lesson are, at the end of this presentation, you should be able to state that the motion of a projectile moving in a parabolic path has horizontal and vertical components. Draw velocity time graphs to represent the horizontal and vertical components of the motion of the projectile. And use the velocity time graphs to solve problems involving the projectile motion. And then we'll go way over to electricity and magnetism, and we're going to relate the motion of a charged particle in through an electric field to projectile motion. And these are some of the things that you should know. You should know how to interpret velocity time graphs. You're supposed to be able to know how to use equations for uniformly accelerated motion, the v equal u plus at and the s equal ut plus half at squared and so on. How to resolve vectors into two mutually perpendicular directions, right? To determine the magnitude and direction of the force of an electric field on a charged particle in it. And in it. Okay, so here we have a football, and we're going to, if this football is kicked, all right, you notice that the football itself is, you're going in a parabolic path. But I want you to take note of the red dot, and the yellow dot. The red dot would be like a shadow of the ball moving along on the ground. So the red dot is moving on the ground along as the ball moves. The yellow dot is like a projection of the ball, and so as the ball moves, the yellow dot goes up when the ball meets its height and it comes back down. So the red dot is moving along the ground, and the yellow dot is moving up and down as the ball goes up and down. All right, so if we were to look at two velocity time graphs to graph the motions of this ball, here we start here. When we look at the red ball, this is moving across with constant velocity. So here we have a velocity time graph, and this represents constant velocity. The yellow dot, as the ball goes up, the velocity decreases to 0, and then it increases in the opposite direction. And so as it goes up, the ball goes up 0, and then it increases in the opposite direction. And so we can draw these two velocity time graphs for the horizontal component of the motion of the ball and for the vertical component of the motion of the ball. All right? Okay. So, these are the features of the projectile motion that we see. We see that the motion of the ball is parabolic. The motion of the ball has two components, a horizontal component and a vertical component. The horizontal component is constant velocity, constant motion, and the vertical component is accelerated motion in the vertical. All right? Okay. So let's look at a little bit more. So this ball is projected with some velocity v at some angle theta to the horizontal. It is kicked with some velocity v. Now when it is kicked, it moves in a parabolic path. This is the path in which the ball moves. That's the parabolic path in which it moves. And it moves some horizontal distance r. Remember the red dot that was going across? That's the horizontal distance it moves. And it also goes up to some vertical height h. This is the maximum height to which the ball goes. It goes up to this maximum height and then it comes down back. All right. Okay. Also, the velocity of the ball has a horizontal component. You can resolve this velocity with which the ball is kicked into two components, a horizontal component, and it can be resolved into a vertical component. I put the vertical in yellow, horizontal in red to color code them. So the velocity has a horizontal component and a vertical component. And further to that, the horizontal component, when you resolve this velocity, the horizontal component would be v cos theta, and the vertical component will be v sin theta. So initially, when this ball is kicked with a velocity v, it has an initial velocity horizontally, a component v cos theta, and it has an initial vertical component of velocity v sin theta. All right. So let's look at the graph. Remember, this red, the motion along the ground is uniform. And so if it leaves with the horizontal component is v cos theta, in this graph, which is for the horizontal motion, the magnitude of the velocity would be v cos theta, that constant magnitude along the ground. Let's look at what happens vertically. Here again, this is kicked, so initially, vertically, the velocity is v sin theta. So it leaves with a maximum velocity v sin theta. It goes to 0 and then it comes back down. And at this point, the velocity would have the same, the vertical component of the velocity will have the same v sin theta, because it takes just as long as it takes to go up, it takes to come down. The same speed with which it leaves the ground, that is the same speed with which it comes back down to the ground. All right. So here we have our vertical component of the velocity represented by the velocity time graph. The magnitude of the velocity initially at time t equals 0 is the v sin theta, which is the vertical component of the velocity. And here we have the horizontal component of the velocity represented on a velocity time graph. The magnitude would be the horizontal component of the velocity of the ball. Okay. So, oh, I'm sorry. All right, so let's move on. Now, what do we know? We want to determine now how far a relationship for how far this ball would travel and what's the maximum height to which it will travel. So we know for a velocity time graph that the velocity or the distance traveled is the area under the graph for that particular time period for which the traveling is taking place. So if we want to determine how far the ball travels, we must go to this graph, because this is our horizontal velocity graph. And so if we determine the area under this graph here, if we determine this area under the graph, this area here, that is numerically equal to the horizontal distance that the ball travels. And so here we know that this is a rectangle. The time t, this is t on the x-axis, and we know that the magnitude of the velocity is v cos theta. So that the distance r traveled would be length or width times length, v cos theta times t. All right. Now, similarly to going up to the height h, to the maximum height, remember this is, at this point, the ball is at its maximum height. So if we find the area under the graph, this little area here under the graph, we find that area there under the graph, that should give us what the maximum height to which the ball travels. All right. So, and that height. Now remember, this is a triangle. This t half, because the ball takes the same time to go up as it takes to come down, if the full time is t, because this would be half the time it takes the ball to go up and come down. And so when we determine the area, it's a triangle, so it is half base times height. So it will be half t half times v sine theta, and that will give you the distance or the height to which the ball travels. Okay, so we are using our velocity time graphs for the horizontal motion, which is the constant motion, and the velocity time graph for the vertical component of the motion, which is linearly accelerated motion, in order to determine the distance, the horizontal distance that the ball will travel, and the maximum height to which it will go. All right, and so we have ended up with those two equations. So here we'll do a little math, or a little use some of our equations. Now, for going up, we can use the equation v is equal to u plus at. Now, when the ball is going up, remember we're looking at the vertical component now. When the ball is going up, any vector that is in the direction of upwards, that vector will be positive, and any vector that is downwards, that vector will be negative. And so at the highest point of the ball's trajectory, remember the velocity would be 0. Remember the yellow dot went and it stopped, and then it came back down. So right at the peak of the trajectory, the vertical component of the velocity is 0. And so at the peak of its trajectory, remember we're using v is equal u plus at. So for the vertical motion, at the peak, v is 0. Remember the initial velocity for the vertical component is u v sine theta. And we will, because g, which is the acceleration due to gravity, is always downwards, that has a negative sign, and the time it takes to meet to the top of its trajectory is t half, and that's how we get this equation. And so we can rearrange the t half is equal to v sine theta times g. But you remember let me go back to the last slide. Remember, we had that h is equal to half v sine theta t half, and we worked out that t half is v sine theta. And so when we make the substitution, we end up with h is equal to half v squared sine squared theta g over g. And so that's an equation that comes out of the analysis from the velocity time graphs of the projectile motion. And this is an important equation that you will use in order, and you may have come across this if you have done it from that other different approach. All right. Now let's look for the horizontal distance. I'll go back 2 slides. All right, I'll go back 2 slides. Remember, the horizontal distance is r equal v cos theta times t. Okay? All right. And now what we do know is that this time t is 2 times t half. T is 2 times t half. Okay? And so if we go back these 2 slides here, remember t is 2 times t half, and t half we said was v sine theta over g. So we multiply that by 2, and then we make the substitution for t, and when we will end up with this other significant equation for the horizontal distance travel, which is v squared sine 2 theta over g. So we have those two equations that would be derived using the velocity time graphs. And it's very important to understand that the projectile motion, when the projectile is moving in its parabolic path, that it has two components, a vertical component of its motion and a horizontal component. The vertical component has linearly accelerated motion because it is under the influence of gravity, and which provides a force that will change the velocity. The horizontal component has no external force in the direction of its motion, and so that will be constant. Okay, and so the two graphs would represent those two types of motion. All right, let's look at a question here, a sample question. It says the graphs show the vertical and horizontal components of the motion of a projectile that is projected with velocity 20 meters per second. Determine A, the angle of projection, B, the maximum height to which the projectile reaches, and C, the horizontal distance the projectile travels. Now I want you to try to follow me as I go through the solution to this, and these are the graphs. So we see here this maximum velocity starts off with a velocity of 10 meters per second in the vertical direction, because remember, if you look at this, when we had color coded, this would have been yellow. This is your graph, and this here is some velocity v, which we will have to determine. So we know, what we know is that if we recall that this here was v sine theta, okay, where v is the velocity of projection. So if in this case, this here is 10, all right, and we said it is projected with a velocity of 20 meters per second, okay, so v is 20. So this here, for this particular question, would be 20 sine theta. But the 20 sine theta on the graph, we can write that the 20 sine theta is equal to 10, because on this graph, this value is 10, but this would be 20 sine. So sine theta would be equal to 10 over 20, and that would be 0.5. And sine inverse of 0.5 would be 30 degrees. So that the angle of projection based on this would be 30 degrees. That's part A. Now, the maximum height to which the projectile reaches, you remember that is this area here. This area under here would give you the numerically equal to the maximum height to which this projectile, and remember this is 10 meters per second, and this is t in seconds, and this here is 0.5 seconds, 0.5, and then here is 1.0. So this is part A. Part B now, what we know that this shaded area is numerically equal to the height to which the projectile travels, and so that the projectile, the height h would be equal to half by 10 by 5, and that would be 25 meters, right? Half by 10, half of 50, 25 meters. Okay. Part C requires, now if we want to determine what the horizontal distance would be, it will be v times 1, because this here, remember this is v, and this is 1.0 seconds. This area would be the horizontal distance that this thing travels. All right, but what we need to determine first is v. I'll erase this first part here. This is part C. We know that r is equal to V times 1. Now, in order to find out, we'll have to find a value for V. But remember, the angle of projection worked out to be 30 degrees. We worked out the angle of projection to be 30 degrees. And remember, we said that this here on the graph, if you remember, I'll go back a few paces. All right. V cos theta. All right. V cos theta. Remember, we said that R is equal to V cos theta times T. So T is 1 in this case, and this here is V cos theta. But remember that we said that the angle of projection was 30 degrees. All right. So we can write R is equal to V cos 30 times 1. And V was 20 meters per second. So that would be 20 cos 30 times 1. And cos 30 is 0.87, about there. That would be 20 times 0.87, 2714, 17.4 meters. So it goes up to a maximum height of 25 meters, and it goes a distance of, yes, it goes to a distance, I think that H, this is not 5, but this is 0.5. I'm sorry, my apologies. 10 times 2.5 meters, I'm sorry. Goes up to a maximum height of 2.5 meters and a horizontal distance of 17.4 meters. So here we see where we are using the velocity time graphs of the horizontal and vertical components of the motion in order to determine the parameters with regard to projectile motion. Okay, so I'll go forward now. All right, so we'll move to another scenario here. Here we have two charged electric plates, one positively charged, one negatively charged, and when that happens, we have a uniform electric field in between them. This is a charged particle, it's positively charged, red positive, and it's moving in a horizontal direction. And let's see what happens. Now, when it enters into the electric field, it begins to experience a downward force which causes it to move in a parabolic path. So this is the downward force. As soon as it enters into the electric field, it experiences a downward force which causes it to move in a parabolic path. All right? And so if we, again, let me just, again, here we have the particle is moving across horizontally, just in the same way. That would be your constant motion. But in this case, it is starting from 0 and it is going to a negative maximum velocity, because remember, this force is causing it to accelerate downwards at the same time it is moving across. And so the particle will move with that. This would represent the vertical component of the motion of the particle. All right, so here we have the particle. This is the parabolic path in which the particle is moving, and this is the forces which is exerted on it. Okay, so the particle is moving with a horizontal velocity. At the same time, it is experiencing a downward force. Now we know what you would have expected to have known, that if you have a charged particle with charge Q, this is a particle with charge Q in an electric field of magnitude E, then this particle will experience a force, and the magnitude of that force will be equal to the electric field times the charge on the particle. And that is why this EQ is here, because that is the force that the particle will begin to experience as it enters into that electric field there. All right. Also, the particle will travel some horizontal distance r, and it will fall some height h because it is going in that parabolic path. Okay. Now, again, we have, these are the graphs for the horizontal motion. This is the horizontal and vertical. Color-coded horizontal red, vertical yellow. Here again, if we want to determine what is the horizontal distance that it travels, we must take the area under the graph. And so when we take the area under the graph, we get that r is v times t, whatever v is. And if we want to determine the vertical height through which it falls, we must take the area under the graph, and h is equal to EQ over m times t squared. So we will look on how that is determined. So let's look on how we determine this here. You remember that the force is equal to E times Q. But from Newton's law, acceleration is equal to force over mass. And that would be equal to EQ over m, where m is the mass of the particle. Okay? So that's acceleration. Now, if we use the linearly accelerated motion for the vertical component of the motion of the particle, we can use the equation V is equal to U plus AT. Okay? Now, since this particle is projected horizontally initially, it has no initial vertical component. So that vertically U would be 0. And so vertically we will have that V is equal to A times T. All right. We're gonna take a break here, and when we come back, we will look a little bit more on this and look at a sample question. More on Schools Not Out after the break.
Get moving! Home workout series with Jamaica Moves.
Jamaica move, mobilize, exercise. Jamaica move, Jamaica move, Jamaica move, mobilize, exercise. Come on, take a selfie, breathe.
Mondays, Wednesdays, and Fridays at 8:35 a.m.
Hi! We haven't left you out. It's Get Moving Kids.
Wall Street above, we're moving.
Home workout series with Jamaica Moves. Tuesdays, Thursdays, and Fridays at 2 p.m. on TVJ. Hi!
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much.
Reduce your risk of viral illnesses like the flu and coronavirus. Wash your hands frequently with soap and water. Cover your nose and mouth when coughing with a tissue and dispose of it. Avoid close contact with anyone with a cold or flu-like symptoms. If you become ill, please visit your doctor or the nearest health center and share your travel history. The flu and coronavirus can kill. Let's protect each other. A message from the Ministry of Health and Wellness.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.
COVID-19 tip. Protect yourself and others from getting sick by washing your hands after coughing or sneezing, when caring for the sick, before, during, and after you prepare food, before eating, after toilet use, when hands are visibly dirty, and after handling animals or animal waste.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.
Reduce your risk of viral illnesses like the flu and coronavirus. Wash your hands frequently with soap and water. Cover your nose and mouth when coughing with a tissue and dispose of it. Avoid close contact with anyone with a cold or flu-like symptoms. If you become ill, please visit your doctor or the nearest health center and share your travel history. The flu and coronavirus can kill. Let's protect each other. A message from the Ministry of Health and Wellness.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you.
Welcome back to Schools Not Out, your daily classroom for CSEC and CAPE subjects. We're talking multiple choice in CAPE physics. We're really talking projectile motion in CAPE physics. That's my error. Okay. Where we left off, we were looking at a charged particle moving through an electric field, and we had likened it to projectile motion. Slight difference from the ball being kicked. When the ball was kicked, the ball went up and then came down. In this case, the particle is moving in a horizontally, and because of the force of the electric field, it causes it to move in a parabolic path. So initially, when this particle is moving, it has no vertical component of its velocity. Its velocity doesn't have a vertical component because it is moving horizontally. So the initial velocity, and that is what we would have applied here. Remember, this is all, I will put this here, I'll put red markers, well, it's yellow for vertical. I don't have yellow, but I'll use blue. All of this is representing vertical motion, okay? So that the velocity with which this particle strikes the ground, the vertical component of the velocity with which this particle strikes the bottom plate. So this is moving like this. So at this point, the particle has a vertical component of its velocity and it has a horizontal component. So this V that we're speaking here is the vertical component of the particle, of the velocity of the particle when it strikes the ground, the bottom plate. All right? And so we know that A is equal EQ over M, and since V is equal to AT, that's equal to EQ over M times T. And from the graph, remember this is a triangle, so it is half base times the height of the triangle. And this is the point at which the particle strikes the bottom plate, so it has velocity EQ over M times T. And so H is half. There is an error here. This ought to have an half there. Right? H is half EQ over MT times T, half base times height. And so this is what H would be equal to. So here, there is an error. There ought to be a half there. Okay? All right. So this is how we... So what I want us to look at a question, a sample question. And please remember, if you have any questions, you can send them in, and I will just stop what I'm doing and try to attempt to answer the question. All right, but in the meanwhile, we'll just look at this sample question. It says a particle of mass 0.2 micrograms with charge of 10 microcoulombs is projected horizontally with velocity of 4.5 by 10 to the 3 meters per second into a region between two charged parallel plates. The electric field E between the plates is of magnitude 200 newtons per coulomb. Determine whether the particle would leave the region of the electric field. So we're saying that when this particle enters the electric field, it will experience a downward force which will cause it to move in a parabolic path. Now, if the force is strong enough, the particle could come here and crash into this plate. It wouldn't leave the field. Or if the force is not strong enough or the velocity is high enough, the particle can, even though moving in a parabolic path, it will escape the field. All right? Now, what we're wanting to find out really, if the horizontal distance is anything less than 0.1 meters, that means this thing would have crashed into the plate and it hadn't left the field. If it is anything greater than 0.1 meter, we know that it would have escaped the field because it would have not have met to this level in the 0.1 meter. So that's basically what the question is asking you. What is the horizontal distance to which this particle has traveled with all of these given parameters? And if the horizontal distance is less than 0.1, we know it would have crashed into the plate and it hadn't left the field. If it is greater than 0.1, it has escaped the field. All right, so that's fundamentally what the question is asking us. So let's apply the principles to see what transpires. All right. So we can make the determination. Let's go back and keep in focus. Remember now, we can determine we know that the horizontal distance that it travels is R is equal to V times T, okay? And if we can determine, now we know that V is 4.5 by 10 to the negative 3. That would be equal 4.5 by 10 to the negative 3 by T meters. Now, our task is to find T. But we can find T because we know the height through which it must fall before it hits the plate. We know the mass, we know the charge, and we know the electric field strength. And remember that H is equal to half EQ over M T squared. Okay. So we can determine, when we know that H, the height through which it falls, is 0.05 meters. So T would be equal, H, 0.05, half is 0.5, E is 200 newtons per coulomb, Q, the charge on the particle, is 10 microcoulombs. That would be 10 by 10 to the negative 6 micro, that's that, times T squared all over. And the mass of the particle is 0.2 micrograms, which is 0.2 micro 10 to the negative 6, and then we must change that to kilograms by multiplying by 10 to the negative 3. We can do all of the cross multiplication. Let me see. This is 0.5 by 200 is 10 to the negative 2, 10 squared. That's 100. That would be 0.2 by 0.5 by 10 to the negative 6 by 10 to the negative 3 all over 100 by 10 to the negative 6. 0.05. All right. All of that would be equal to t squared. Now, when we find the value, we can calculate this and determine the value for t. 0.0. We can determine the value for t, and then when we get the value for t, we substitute it in this equation here in order to find a value for r. Let's see if we can 0.05. This is 0.01, 0.05 by 10 to the negative 9, 0.05 by 10 to the negative 9 over 10 to the negative 4 equal t squared. So t would be equal to 0.05 by 10 to the negative 5, which is 5 by 10 to the negative 7, which would be equal to 0.5 by 10 to the negative 6 t squared, and that would be 0.22 by 10 to the negative 3, or 2.2 by 10 to the negative 4 seconds. You can check my calculations, right? And then you can take this now and substitute it in this equation, and so you will have r is equal to 4.5 by 10 to the negative 3 by 2.2 by 10 to the negative 4. And if this is greater than 0.1, if this is greater than 0.1, let me go to my basic arithmetic. Remember this here, 4.5 by 2.2, 2 5 is 10, 2 4 is 8, 1 9. That we have 9.9. That would be 9.9 by 10 to the negative 1, and that would be equal 10 to the, this is cubed, so I'm sorry, this is velocity, and that will be 0.99 meters, which is greater than 0.1 meter, so this thing would escape the electric field. I hope that this lesson was helpful to you. If you review it, it's just another approach. All right, and you can catch a repeat of today's lesson on JNN later, and at 4 p.m. and in Schools Not Out highlights on Saturday between 1 and 4 p.m. It will also be on video on demand on onespotmedia.com. All the best for your examinations. Work hard, study hard, and do well.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much.
Reduce your risk of viral illnesses like the flu and coronavirus. Wash your hands frequently with soap and water. Cover your nose and mouth when coughing with a tissue and dispose of it. Avoid